Okay, today we're going to do logarithmic functions. The problems are going to come as we're doing the problems. I'm going to tell you what they are. So log functions look like this. This is kind of like what I was talking about when we did exponential functions. This base is always going to be there, so it's not affecting my my change to the parent function. So if I have something that tells me this 3 doesn't matter, that's just part of the parent function. The parent function would then be so what changed? Well, I got a 3 right here. My A is a 3, which is going to be a vertical stretch by a factor of 3. I don't have a B value. My H is -1, so that's going to move me to the left 1. And my K is -9, so that's going to move me down 9. So we're still doing the same stuff that we did before, but just this little guy is like the big B that I did with exponential functions. It doesn't really matter. The only thing that it does is it kind of changes the way the graph looks a little bit. We're not gonna focus too much on that, okay? So when I'm looking at this, I'm looking at what's changing here, all right? We're also gonna do domain and range, but we're gonna do that in class. So the first problem that I want you to turn in to me is tell me the change to the parent function. I'll use a log base 3 on this one as well of So tell me the change to the parent function with this guy. Now, the reason that we used logs in the first place is to solve exponential functions. You guys should remember this from Algebra 2. If I had something that told me, exponential equations. If I had something that told me 3 to the x plus 1 equals 17, the way that I get, actually, let me change this so I can get an integer. So I'm gonna make this 81. So the way that I get rid of a base when I have a variable in the exponent is I do the log with that same base. So I do the log base 3 to each side. I'm gonna rewrite this so that it's more followable. So I have log base 3 of 3 to the power of x plus 1 equals log base 3 of 81. This is a number. I can plug it into the calculator. When I plug it into the calculator, it tells me 3. When I have an exponent on a log, it comes down to the front. So that means it's x plus 1 times the log base 3 of 3. The reason that I did this is because it cancels out, meaning that the log base 3 of 3 is 1. So I have x plus 1 times 1 equals 3. X plus 1 equals 3. I subtract the 1 and x equals 2. So that's how I'm going to solve these out, is by using logs. Now, log base, the same base of the of, is what we're always going to do to cancel it out. So if I have something that tells me e to the power of 7x plus 1 equals 14, the way I'm going to get rid of that e is I'm going to do the natural log. The natural log is ln, and I write the L like that so it doesn't look like a 1. So I'm going to do the natural log of each side. So I have 7x plus 1 times the natural log of e equals the natural log of 14. We're going to use exact answers, so we're not going to put this in the calculator because it's going to give us an irrational number. This equals 1. So I have 7x plus 1 equals the natural log of 14. I'm going to subtract 1 from each side. This is my of, so I can't do 14 minus 1. What I have to do is natural log of 14 minus 1. These can't be combined. And then I'm going to divide by 7. So my x is going to equal the natural log of 14 minus 1 over 7. And these, because I'm getting a solution, should be written in roster notation. My last answer should have been in roster notation as well. Okay, now we do have to check for restrictions sometimes when we're doing these, when we're using exponentials to solve logs, but not when we're doing logs to solve exponentials. So what I mean by that is, when I have something that tells me the log base 3 of x plus 2 equals 4, this part right here cannot be, it can't be 0, it can't be a negative, okay? I cannot do the log of 0. I cannot do a negative number in here. So because of that, when I solve it out, I'm also going to say that x plus 2 has to be greater than 0. Can't be a negative and it can't be 0, so I have to solve it like that. So I solve this, and I know that my solution has to be bigger than negative 2. So if when I solve it, it gives me negative 10 or something like that, I would say no solution. So let's solve this out. The way that we get rid of this is what we do is exponify. So that's going to become an exponent. That's going to become an exponent. This cancels out. These cancel each other out. So it really equals x plus 2 equals 3 to the 4. 3 to the 4 is 81. Subtract the 2, and I get x equals 79, which is greater than negative 2, so that is the solution. So I put it in roster notation. So that's the main thing that we're going to be doing today, okay? We're going to do a little bit with the domain and range in class. The second problem that I want you to solve is I want you to do log base 4 of 2x minus 9 equals 4. I was going to say 14, but that's going to be too big. I'll just do 4. So I want you to solve that problem, okay? Now, why do we actually do logs? Ooh, I don't have a blank paper. I'm just going to use the back of this. Because if I'm doing something where I say, hey, I'm investing $10,000 into a bank account that gets 2.29% interest, and I'm investing it where it compounds continuously, and I want to figure out how many years do I have to invest it before I get $100,000. The way that I do that is I set this up. This is how much I want to get. $100,000 equals the starting amount. It was compounding continuously, so this is an e to the power of the rate as a decimal, 0.0229, times the time. The time is the only thing I don't know. So first thing I'm going to do is divide by 10,000. So I get 10 equals e to the 0.0229t. The way I can get rid of this e and get this out of the exponent is by doing a natural log. So the natural log of 10 equals 0.0229t. And then I'm going to divide by 0.0229. And this tells me how many years I have to do it. So let me get my calculator. Sorry this video is so long, guys. Natural log of 10 divided by 0.0229 tells me 6.0792 years. So I'm going to do 0.0792 times 12 times 12. It gives me 6 years and 0.95 months. So about 6 years and 1 month. After that amount of time, I'll have $100,000. So what I want you guys to do is you're investing $5,000 at 14.2% compounded continuously, and I want you to figure out how long until you have $50,000. And those are your 3 problems.